The next kind of simple machine that we're going to look at is called a pulley. And a pulley is also going to magnify the force that you apply. So let's take this setup that this is a box that you want to lift. It's going to have a weight F load. And now let's say that you try to use a rope. So then you take a rope, you connect it to the load, and you try to pull on the rope with your hands to lift it upwards. So you're going to apply a force FA. But typically the load is a lot bigger than you applied force, so this FA here is not going to be, you're not going to be able to apply a large enough force to lift up the load. So you want to figure out a way to magnify the force that you apply. So we're going to use another setup, and this setup is going to be a pulley. So what you're going to do is, instead of having your hands here, you're going to take a disc, and you're going to connect the rope that is connected to the load that you want to lift to the center of a disc. And then you're going to, so this is going to be the ceiling now. And you're going to take another rope, and you're going to fix it to the ceiling here. And then you're going to pass that rope through the disc, and you are going to pull with your hands on this side here. So this is where you're going to apply the force. So you're going to apply the force FA along the rope. And what you'll find is that because this rope here is fixed to the ceiling, that actually is going to be a way to, the ceiling is also going to help in lifting the force in lifting the load as well. So that means that instead of you exerting all your effort by yourself to lift up the load, you and this fixed point here, the ceiling, are going to work together to lift up the load. So let me restate these forces more specifically here. The force that you apply along the rope, that has a special name. This is called a tension force. So the force that you apply along the rope. So I'm just going to say here F rope. The technical name for that is a tension force. So you apply a force along a rope to give it a tension Ft. And what you'll find is that that's going to be you're going to be able to lift up the load. And so let me make this a more specific example now. So let's say that you have the load that you want. This is the floor. You have the load that you want to lift. So you're going to set up a pulley. So this is the fixed point on the ceiling here, and you have your disc. And so the load, this is F load here, and you want to lift it. So you take the rope. You first of all, you connect the load to the center of the disc, and then you're going to take this rope, thread it through the pulley, and this is where you're going to apply the force or the tension. So this is going to be the applied force. So in this particular example, let me just redraw that again here. So here, the magnification depends on the number of strings that are connected across the pulley. So in this case here, let's say that the load weighs 6 newtons. So what you're going to find is that if you connect the pulley, if there are 2 ropes connected across the pulley, that's going to double the force that you're able to apply. So what that means is that, so you can see here, there's a rope on this side, a rope on that side. So there's 2 strands of rope connected across a pulley, and that's going to double the force that you apply. So that means that you only have to apply 3 newtons, and the rope is gonna, because it's connected by these 2 strands here, that's gonna double the force that you apply, so you can lift up 6 newtons. So then what you can say is that you applied a force of 3 newtons, and then the pulley magnified your force, and then you're able to lift an object that had a load force of 6 newtons. So again, the pulley magnified your force. And we're going to use a similar equation to the previous ones. And it's the same equation actually. For a pulley, if you apply a force FA, the pulley is going to have a magnification or mechanical advantage MA. And that's going to be able to magnify your force so that you can lift the load FL. So that is the same equation as as the last 2 simple machines. The only thing is that a pulley is going to have a different mechanical advantage. And for a pulley in particular, the mechanical advantage, so I'll say mechanical advantage of a pulley, It actually depends on the number of strings or the number of ropes that are connected around the pulley, where N is the number of ropes around the pulley. Number of ropes or strings around the pulley. All right, so let's look at some applications of pulleys. So if you look at this picture here, the mass is connected directly to the pulley, and so there's only one string across the pulley here. So that means that there's going to be a one-to-one relationship. So the force that you apply is going to be the same as the force that you lift. So there's actually no magnification here. But in this case here, across the pulley that's connected to the load, you have one rope, two ropes. So that means that that's going to double the force that you apply. So if you exert a applied force that is able to raise 50 grams, the pulley is going to double that, so you can raise 100 grams. In this case here, this is the load that you want to lift, and you connect it to 1, 2, 3, 4 pulleys. So that means that if you apply a force that is able to lift up 25 kilograms, that's going to quadruple the force that you can lift, so you'll actually be able to raise 100 kilograms. So the point is that for a pulley, the mechanical advantage depends on the number of strings that are connected around the pulley that's connected to the load.